Here's the second example of a conditional probability question. It's a little bit more complicated this time. Horace turns up at school either late or on time. He is then either shouted at or not. So the chances that he's late are 0.4. If he turns up late, the chances of being shouted at are 0.7. And if he's on time but shouted at anyway for no particular reason, the chances of that are 0.2. So you hear him being shouted at, so that's given, that's definitely happening. What's the probability that he was late? Well, rewriting this using notation, we can see that we're looking for the probability that he was late, given that we hear shouting. So I'm setting up my tree diagram with a column for my first event, my second event, my outcomes, my probability. Now, when I'm making out my tree diagram this time, I'm going to think about the natural order in which these events might occur. So in this particular case, he turned up either late or on time first. So I'm going to put that in the first column. So Horace is either late or not late. From the question earlier, the probability that he was late was 0.4. And of course, that means the probability he was not late was 0.6. And now I know that if he was late, the probability he was shouted at was 0.7. So that means that if he was late, the probability of not being shouted at was 0.3. Now, if he was not late, there's still a chance he'll get shouted at. Poor old Horace. So the chances in that scenario are 0.2, which means that if he's not late, the chances of not getting shouted at are 0.8. So now that I've got all my events filled in, I can list out my outcomes and my probabilities. So my outcomes are late shouted, late not shouted, not late shouted, and not late not shouted. So my probabilities are, as you can see. And again, no harm to just tot those up and check that they add up to 1. And they do, in fact. So again, what are we trying to find? The probability that he is late, given that we hear shouting. So let's go back and use our formula so that we know how we're going to proceed. So I need to put on top the probability that he is late and I hear shouting over the probability that I hear shouting. So the first is easy to identify. The probability that he is late and I hear shouting is just my first entry in my outcomes here. It's 0.28. And the probability that I hear shouting, well, there's actually a couple of outcomes that have shouting in them. Poor old Horace again. So this outcome and this outcome both have shouting in them. So I want to include both of those in my probability of shouting. So that's 0.28 and 0.12, which is 0.4. When I simplify this, I'm going to get 0.7. So if I hear shouting, the probability that Horace is late is 0.7.